everybody. Today we're going to be talking about calculations for heat and specific heat. So we've got Q and C here. So when we look at this equation in particular, we notice that it is just rearranged from this equation over here where we've taken the mass and the change in temperature and divided each side by that. So we end up with specific heat equals Q over M times the change in temperature. So one cool tool that I've used in the past is a nice triangle. So I'm going to draw a triangle here. And we're going to draw some spaces in that triangle. So we're going to put a Q on top, then we're going to put a C, an M, and a delta T. And so for this particular calculations that we might be using, if you need to solve for a particular variable, you can put your finger over that variable. So for example, if I needed to solve for C, the equation I would use would be Q divided by mass times the change in temperature. Or if I needed to solve for Q, I would multiply the specific heat times the mass times the change in temperature. Or if I needed to solve for mass, I could solve for Q divided by the specific heat times the change in temperature. So let's look at a couple practice problems for this. So if we have our notes for today, we'll notice that we have a question where it says, if 23,000 joules of energy are used to heat water by 4 degrees Celsius, what is the mass of the water? So we have joules of energy, which is our Q. We have a change in temperature, up here, which is delta C, not delta C, delta T. And then we also know that the specific heat of water is 4.18 joules per gram degrees Celsius. So currently we have Q, C, and delta T, and we're looking for mass, which means we would need to cover the mass, and we know that to calculate mass, that's going to be equivalent to Q over C times delta T. So let's get those numbers from here. So we've got mass is going to be equal to 23,000 joules divided by the specific heat of water, which is 4.18 joules per gram degrees Celsius, times the change in temperature, which is 4 degrees Celsius. And then we should be able to get an answer from that. It's really important when you do these calculations in your calculator that you're using appropriate parentheses. So we're going to take 23,000 and we're going to divide it in parentheses 4.18 times 4. If you don't put that in parentheses, then you're going to get the wrong answer. So you'll see for this we get 1,375, and our units here would be grams because we're looking for mass. All right, let's look at another one really quick. So just below that, we've got 23,000 joules of energy used to heat mercury by 4 degrees Celsius. So we would want to find the mass of that. We're going to do the same calculation we just did. I'm not going to do that one for you because we just did that calculation. The next one we have, what is the specific heat of aluminum if 4,750 joules of heat energy is added to 249 grams of aluminum to produce a total temperature change of 21.1 degrees Celsius. So in this case, we're looking for specific heat. So for specific heat, let's inch this down a little bit. We would cover the C, which is specific heat. So C would be equivalent to Q over M times delta T. So if we want to calculate the specific heat from the information that we have 4,750 joules. We're going to divide that by the mass of the substance, in this case 249 grams of aluminum, times the temperature change, which was 21.1 degrees Celsius. And that's going to be equivalent to, let's put it into our calculator, 4,750 divided by, and then remember you need those parentheses for the bottom portion. So the specific heat is going to be 0.90, and then if we look at units, none of them cancel, so it's joules per gram degree Celsius. All right, I hope the triangle helps you with your calculations. Thanks for listening.